All right, so let's get started showing these constraints. The first one I'm going to show is going to be the copy location constraint. So I'm going to select my target, shift select the owner, use the shortcut Control Shift C, and then from my menu here, I'm going to choose copy a location. Now it's time to explain some of the settings that are specific to these constraints. So with the head and the tail, I can specify which percentage along the bone that we want it to copy. All the way to the left is the head of the bone, or 0, and all the way to the right is the tail of the bone, or 1.0. Now what does this little Bezier line do? If we click that and then slide, you'll see it's floating around in the air. Now how is it doing that? Well, that's just because I've already gone ahead and I've added a curve to this bendy bone. And remember, that's only visible when we're in B-bone display mode. So now jump back to that, you'll see it's sliding along that bendy bone. If we have this disabled, it's going to just slide between the head and the tail in a straight line. With these X, Y, and Z axes, we can tell the constraint which axes we want it to follow. I have disabled the X and the Y, so it's only going to follow along with the Z axis. And the invert button will move in the opposite direction. So I'll just enable the X invert. So when it moves in the X axis, the owner is going to move in the opposite direction. And that will work exactly the same on the other axes here. This offset checkbox, when we enable that, it's going to add the original location into the copied location. So that pretty much means it's going to jump back to its starting position, but we can move this one around. If we have this one disabled and we try and move it, you'll notice that it has no effect because the constraint is telling it where to stick. And now the other settings, the space settings for the target space and the owner space, I've spoken about them in a different video. And I've already explained the influence and this little button down here. All right, let's move on to the next one. The copy rotation constraint isn't too complicated to understand. I've already gone ahead and set it up here. And you'll also notice that I've left the other constraint on there, but I have disabled it in case you're wondering what that is. But with the default settings, when I rotate our target here, the owner is going to copy that rotation. And that makes a lot of sense. We do have a lot of settings here. We have the order. Now this is actually the rotation order. Now at the beginner's level, you can just leave this alone as it's not something you're ever likely going to need to adjust. Rotation order is a little bit complicated, but changing the order is going to change the order in which the axes are calculated and it'll give you a different result. But just knowing that you can change it and you don't need to is enough for you to know about for now. Now the axes and the invert options work exactly the same as the other previous constraint. You can disable or invert any particular axis you like. Now this mix setting is where things get interesting. These are the particulars of how Blender will mix the output of the constraint with the rotation of the owner. The replace option will ignore any of the rotations on our owner and just replace it with the constraint. So that's going to override any of our local rotations here. If we choose add, it's going to add the output of our constraint to the owner there. And if you're wondering why it's off in the weird space, that's because of we're in world and world space. If we put it to local and local, it'll look a little bit better. So now it's going to add the rotations of this to the local rotations. So we can still move this guy here. Now the next two, the before and after original, this is going to affect the order in which it does its calculations. So if you choose before original, it's going to treat the constraint like a parent. So it will calculate all the rotations of that constraint before the local rotations are calculated. And if you choose after original, it will do that in the opposite order. It'll calculate the local transformations before it does the constraint. Now this is not something you need to worry about in the beginning. It's one of those things that you might use later down the track. In the beginning, you're just going to be using replace most of the time, and then sometimes you might be using add. Now what's this one down the bottom here? Offset and then in brackets legacy. This is just to keep backwards compatibility for really old versions of Blender. The constraint just had a checkbox. And if you're using an old rig, you might need to use this setting just to keep it compatible with newer versions of Blender. But if you're creating something today, you can safely ignore this one too. And that's our copy rotation. So I've already gone ahead and added the copy scale constraint and muted the other ones. And you'll see a lot of the same settings. So this is just going to work the way that you expect. When we scale the target, the owner is going to be scaled, and we can tell it to disable some of the axes if we want. If we don't want it to follow the X and the Y, for example, we can disable that there. The power setting is an interesting one. I'll just scale this one bigger so we can have a look. When we leave it at 1, which is a default, it's going to copy at a 1 for 1. But if I drop this down to 0.5 for example, it's going to work just like maths class as an exponent of 0.5. So x to the power of 0.5. Or if we make it bigger, let's say 2 for example, it's going to be x to the power of 2. So if we scale this one up, you can see that the effect that that has. Now I dare say you probably never need that, but it's nice to know that it's there for one of those rare occasions where you're like, wouldn't it be nice if I could raise this to the power of 2? Well, you can. The Make Uniform checkbox here will average the scale across all 3 axes. What I'm talking about here, I have the target that's scaled at 5, 2, and 1. And if I enable Make Uniform, you'll see that it is going to average that across all of the axes. And just to prove what it's doing, I'm going to keep the transforms here. Boom, and you'll see that that is the averaged amount across all of the 3 axes. The offset setting here is a lot like our copy location constraint offset. If we don't have this enabled, then we can't scale this one at all. It's going to be overridden by the constraint. However, if we do enable it, we can scale this one and scale the target. So that's what the offset does. And the additive option here is also another legacy item. In older versions of Blender, the 2.7 series, it used addition instead of multiplication. So I dare say that you won't need to enable this one either. And underneath that, we have our target space and owner space and the influence. And as you know, everything here we've already explained. And the last constraint that we're going to talk about in this video is the copy transforms constraint. So I'll just add that one now. All of our other ones are muted. And you can see that it jumped over the top. Now the copy transform constraint is basically going to do all of these constraints all in one. It's going to copy the location, the rotation, and the scale. But you notice we have less options here. So if you needed to turn on and off or invert any of the individual axes, you can't do that with the copy transform constraint. You'll have to actually break it up into all of the other ones. But if you do want your bone to follow along with all of those ones without anything fancy going on, this is the constraint that you want to use. Just like one of our other ones, you can choose the head or the tail and also the bendy bone version of that. I'll talk about the target shear in just a moment, but if we open up our mix options here, we already know what replace is going to do. It's going to replace all of our local transforms with the transforms from our constraint. But you can see we have 3 options for before and 3 options for after. You already know what the before and the after mean. If you choose any one of the before options, that's going to calculate the constraint before any of the local transformations. And if you choose any of the after options, it's going to do it in the reverse order. It'll do the local calculations before the constraint calculations. As for the other settings, it's best if I show you what it's kind of doing under the hood. Not that you need to understand it now, but it's good to get a base understanding of what Blender is going to do under the hood. For the first option, we have full, and that's going to do our location, rotation, and scale as one big matrix calculation and then dump it into the location, rotation, and scale matrix of the output. So it's pretty much doing all of the calculations at once. This is fast. However, it is prone to get some shearing, especially if they're rotating and they're scaling. The aligned option is going to do just one single calculation for all of the 3 axes of our location and plug that into the output, but it will split all of the other channels for our rotation and our scale. It's going to calculate them one by one and plug them in like that. And that's going to get rid of some of the shearing that happens when you just do it as one lump sum up here. And then finally, we have the split channels where it's basically going to split every single channel. The location X is going to do first, then location Y, location Z, etc. all the way down. The split channels is going to give you the most accurate result, or what you're expecting rather. However, you only really need to use this when you're doing something fancy. Most of the time we can just use the default full option. But as I said, it's just good to have an understanding of what Blender is doing under the hood. And then finally, our remove target shear option here. This will make Blender do its best to try and mitigate any of the shear that happens to be on the target bone when it does its calculations, and without doing any of the fancy matrix stuff it does in these operations here. And that is our copy transform constraint.